Hey guys, this is Justin Searle here. Just wanted to give you guys a little introduction to my Assessing and Exploiting Control Systems course that we're going to be launching for the first time in a live online version through InGuardians this June. So we've been running this course for the last 7 years through Black Hat, through the SANS Institute, several other conferences, and privately on site for multiple different customers. This course involves how to do penetration testing of control system equipment. So looking at different types of field devices, controllers, industrial control systems, and even industrial IoT type devices. So the course basically is a 4-day course. The very first day we go ahead and we talk about what are control systems, what are the difference between normal control systems and industrial control systems, how do industrial IoT and IoT systems all fit into the whole picture, and what do we do to do penetration testing. So we'll talk about scoping, how to properly scope the engagement, how much level of effort each of the different types of engagements take. And then we'll go ahead and start spending 4 days doing penetration tests on multiple different types of equipment that represents the type of equipment we see in the side of the field. One thing that's very different about this course is we spend a little bit of time in the afternoon of the first day talking about how do we do penetration tests of live production networks. But because of the sensitivity and the risk of our industrial control systems, we don't do a lot of penetration testing inside of our live production networks unless it is turned down. And that's one thing we definitely spend a lot of time inside of the course, is how do we do types of security assessments without affecting the reliability and the safety of our control systems. The majority of the course actually is created around the concept of doing penetration testing, trying to identify zero-day vulnerabilities in multiple different types of control systems, from software installed on Windows and Linux, from embedded devices, the firmware in the embedded devices, the different communications interfaces on those devices. The course does include a $500 kit, which does include elements that are devices that we're going to be doing testing on. It also includes different types of devices that we're using for the testing. So a quick little rundown of those different components is we have our Velocio ACE 1600 PLC that we're going to be doing our penetration tests on for the majority of the first 2 days. We're going to be creating a logical program to install on this Velocio ACE PLC. We'll go ahead and we'll use the programmer. We'll talk about all the different program features, what that process actually looks like. We'll talk about the logic that we're programming on it, and we'll kind of spend a little bit of time digging into that logic, because after we program these PLCs, we're then going to go ahead and do a penetration test on them. And now notice these PLCs, there are no Ethernet ports anywhere on them. In fact, this PLC in particular supports a RS-232 serial interface that we're going to be doing some sniffing and capturing on and some penetration testing on. It includes some digital inputs and some digital outputs. So once we go ahead and have this program, like I said, we'll do different types of assessments against it. We will talk about how can we actually test the logic flaws inside of the programming of this PLC and whatever process it's controlling. Once we go ahead and test for those programming flaws, within the constraints of our logic, we'll talk about how do we actually try to break out of that. How can we do other types of attacks? What are the different areas or levels that we can do? As for testing the serial interfaces, we're going to be using the Searle logic analyzer that you will receive in your kit to be able to capture the RS-232 and decode the RS-232 traffic, so we can actually see what type of traffic is being sent out that serial interface. We'll also be going through and taking and attacking the programming software that actually goes into this. So the software that it comes with is vBuilder and vFactory, and vBuilder and vFactory both speak a proprietary protocol to be able to program and to be able to communicate with this PLC. It does that over a USB bus, so we'll talk about how do we do penetration testing of USB communication channels. How do we capture it? How do we intercept it? How can we decode that that proprietary protocol, how can we go ahead and build our own tools to try to recreate that protocol and extend that protocol, basically building a testing harness that we can then use to go ahead and do fuzzing against that protocol or finding other vulnerabilities that may exist inside of that interface. After those first 2 days, then we're going to be starting to dig into alternate types of communication interfaces. We're going to be spending quite a bit of time playing with some software-defined radio. So everybody will receive an RTL SDR to be able to capture and assess different types of communications that are being sent out. We're going to be focusing primarily on proprietary type of communications in the sub-gigahertz range. So once we go ahead and we talk about the basics and talk about different modulation and capture and demodulate a couple different modulation types, then we'll go ahead and introduce you to another tool that you receive inside of the kit. And this is the Great Scott Gadgets Yardstick. And this device is a device that lets you send signals in the sub-gigahertz range as well as receive signals. So we're going to be using this in tandem with our software-defined radio to be able to basically create your own little wireless testing lab that you can continue using outside of class, allowing you to go ahead and create any type of signals you want and experiment with how to actually capture and decode that. Because that's one of the biggest problems you have when you start messing with software-defined radios is there's a big gap between the different wireless protocols that exist out there. You don't always have means to be able to create them, and even if you do and you buy devices, it doesn't mean you have a very systematic way to be able to make the incremental steps, learning how to do different features inside of wireless communications. Then the final day, we're going to be looking at the embedded world. We're going to be working with the bus pirates to go through and capture and communicate with different EEPROM chips and flash chips. We're going to show you how to go ahead and connect back up and dump the contents of a flash or an EEPROM chip so you can see all the different communications or all the data that's actually stored on side of there. How do we actually go through and try to parse that data, make sense of that data on those different types of systems, as well as how to go through and make changes and modifications of that data. Then we will go ahead and show you the final piece of the kit, and this is going to be a Texas Instruments Launchpad device that allows us to go ahead and test different types of firmware attacks and interfaces to be able to try to dump the firmware off of it, try to disassemble that firmware, and explore different ways to interact with the processor on these boards. Anyway, I hope you guys enjoyed that. That's just a brief little sample. If you do sign up for this first live online course that we are launching in June, we will go ahead and ship you all these different types of these different components for you to be able to use, and we'll spend 4 days playing and exploring the wonderful world of penetration testing with industrial control systems. Hope you guys have a good day. Bye-bye.